Hello, I'm Jeffrey Fox, and I'm teaching this free MOOC in the area of data science entitled Big Data Applications and Analytics. And it's built around what I call the big data ecosystem described in one sentence. This is also called the rallying cry of this course, that we use clouds, we run data analytics, we do this collaboratively, we process big data, and we solve problems in lots of application areas which are typically denoted either X followed by informatics, where X runs over the application area, or E followed by the application area. If you look around the world on the web and all sorts of other sources, you can find the values of X that are listed so far. And other fields like physics, the term physics informatics is not often used, but it's implicitly defined because, as we'll see actually in this course, physics uses informatics a lot. And it certainly has huge data. It's one of the largest sources of big data in the research area. Some applications come from industry, some from the consumer world, and some from research. The education area is called data science, and here's a nifty New York Times article. There are many others, including some nice books, especially recent ones. It's based on a class I gave last spring in the so-called informatics program at Indiana University. And here is the URL for this MOOC you're looking at, bigdatacourse.appspot.com. And here you have a collage of the various fields, X informatics. I mean, these are the application areas that big data is going to be processed in, and it's running over those areas I just recited on the previous slide. And this is just a pictorial representation of them. The actual term X informatics, where X is a general symbol, is actually used in a few places. So if you go to the website, the first thing you would do is to enroll. I've already enrolled, so I don't see that button at the top here. I've logged in and enrolled, and I've used my Google account to do that. And if you look at this web page, you can sort of see a nice banner at the top telling me that, well, it thinks I haven't done very much work on this course. It's like most classes, quite often true computers are wrong, of course, but never mind. And then you will see it's divided into sections. Section 1 through section 12. This course has a 4-level hierarchy. Here we have it again in the syllabus description, section 12. Each section has units. That's the things on this line here, 29 units. A unit, if you like, is sort of equivalent to a lecture. It can be of varying size. Some units are small, others are longish, but typically never much longer than an hour. And then each unit, as we see, is divided into lessons, and lessons are typically 10 minutes long. So this has a 4-level hierarchy: course, section, unit, lesson, which we think is a pretty general structure. And now we have to use Google Course Builder to build what we call CGL MOOC technology, which supports this type of hierarchy. As you see from the syllabus, you will find not only the material described along here, but also various things like assessments. The material is sort of split into probably 3 types, or maybe 4 if you count introduction, 4 types. There are some another introductory discussion of data science. There are application areas, which are the X's: physics, e-commerce, web search, health, sensor, radar. Interspersed between these applications, the value of X, you have the technologies. These technologies fall into 2. There are the actual analytics. These are the algorithms, and they're like clustering and recommender engines and things like that. Those are described in these technology sections. We also describe how to use, in this version of the MOOC, to use Python. And this particular MOOC only uses Python. you can, if you wish, skip the parts that actually require you to use Python. Otherwise, there are some uh, parts of the course where you can benefit by running some Python or writing a very little amount of Python. So you can see here how what makes up the course. So in order to see what's going on in this course, we could press this button, which will give us the PDF, which is the whole syllabus. Alternatively, I told you we had sections, units, and lessons. And every one of those things has a description of what's actually it does. So if we look here, let's go to physics case study. If we click this plus here, we will get down the physics section, which has got a pretty picture, and to the right of the pretty picture, it has a summary of the physics section. After the physics section, we have the different units which the physics section has. The physics section has 4 units. Remember, the unit is roughly a lecture. And you will actually see here, if you go here and you press this unit, you get a unit overview here, which is a summary of the unit. Then you can get the lesson with a lesson overview and so on. So the lessons, remember, are the smallest unit, and a unit consists of a set of consecutive lessons. So it has, this particular unit has 3 lessons. So it's actually a rather short unit. If we go here for unit 8, it will probably have hopefully more units. I suspect actually, this one's also a short unit, 25 minutes. If we go to a longer unit here, it must have more. You see, this one has 8 lessons. And this starts off with the unit overview, and then it's followed by the lesson overviews. So you can really find out in this class what's going on. If I actually click one of these units like this, I will go off to the Google App Engine. It will spawn me the video interface. Here we are. So this is the basic interface to Unit 7, Lesson 1. And you can see, actually, remember, this unit has 3 lessons, and we look at the bottom here. We'll come to this, go to the discussion group. I can actually watch it in a native YouTube fashion. We can get the slides of the unit. We can get the overview of the unit, and then we can get the lesson overview. So that's, of course, the smallest unit. And then we can press here to get the next lesson, or we can press up here to get the next lesson. It's sort of interesting how many times my eyes are closed in these pictures, but that's not a big data issue. So actually, here is the Higgs boson. This particular unit is focused on trying to understand the Higgs boson. Okay, so that's the basic structure of the course. One thing you will be asked to do is to join the discussion on the Google community groups. It has a separate forum for each section, and so we can go to the section 1. Doesn't have a significant number of entries in it at the moment. So every section is represented here, and you can just go through them as you like. And hopefully, as this MOOC gets started, you will find significant discussion here. The other way we will have discussion is advertised at the top here. We will use Google Hangout for in-person discussions. And of course, that Hangout has the little problem that you all have to be there at the same time, which means it's not so good if you're in very different time zones. But it's been found effective to have Hangouts, and we will move the Hangouts across the time of day, so we don't automatically favor those in particular time zones. So that's the actual physical structure of this MOOC. I urge you to explore it. Once you log in and enroll, you can explore it to your heart's content. And logging in and enrolling has no hidden requirements or commitments. You can just do that and never look at anything. Another thing we'd like you to do, which is shown at the, but I should also point out that if you, there are at the bottom here some tabs, and those tabs have all the links to back resources you want. Here are the resources for this particular, there are 5 different links here, which gives you further information for this particular unit. But the other thing we wanted to point out here is the link to tell us what you think. If you click this link, you can enter all your favorite comments and help us to improve what we're doing. Over here, there are links to other MOOCs. I should finish by telling you about the other courses that will be available in this series. So this is a free MOOC. Kati Burner has a free MOOC on information visualization. There's a link down here for that. But there's also a set of what you might call regular courses, but they're taught using MOOC technology. So these consist of actually three courses associated with this particular MOOC. There is an undergraduate class offered next semester, residential Indiana Bloomington students in informatics called I-400 course. There is a residential course to informatics graduate students, I-590. Both of those will have separate interfaces and somewhat different material. The I-590 course, at least, will certainly have Java as an alternative to Python. And it will also allow you to run the applications on a back-end server as well as on your client machine. And the final course might be the most interesting. It is for remote participants. It's part of the data science initiative at Indiana University and corresponds to what we expect to be a certificate in data science corresponding to 4 courses. There will be 4 courses offered this spring. 1 in the health area by David Wild, 1 on cloud computing by Judy Chu, 1 on information by Kati Burner, and then a version of this course here, which is on the big data applications and analytics. Note that the online data science certificate is reasonably well priced. $4,500 will get you the 4 courses. That's the total tuition for 4 courses. And we consider that reasonably competitively priced in this difficult world we live in. So anyway, really just explore this MOOC, give us feedback, learn what you want, and please communicate through the community forums. Thank you very much. This is Jeffrey Fox, Indiana University, signing off. Thank you.